Can we start? Yes, we can start. Hello. We're going to start the next session. It's going to be a keynote speech from Professor Orăsan, who graduated University Babeș-Bolyai in Cluj some 24 years ago. Then had a PhD from the University of Wolverhampton several years later, and continued his research at Wolverhampton as head of the research group in computational linguistics. Currently, I found out that he works at University of Surrey as professor of language and translation technologies, always focusing on machine translation. We especially think of him for his discourse annotation tool, Palinka, which was used many years by master students from the Master of Computational Linguistics in Romania. No doubt that the name helped making the students more interesting about the tools. So Constantin, thank you so much for accepting to join us and to participate in our conference. And please, we are welcoming you to have the talk. Thank you.
Thank you very much for the invitation and for the introduction. It's a pleasure to present at the conference. Yeah, it's a shame I can't be there. Would be lovely, but hey, it's a bit difficult these days to travel. So let me share the screen. Let's see, and you tell me whether it's. Okay, so hopefully you can see the screen. Yeah, and you can hear me. So today I'm going to talk about the research that I've been carrying out recently about translation of sentiment. So this is a theme that has been of interest for me for quite a few years. And some of you may have heard parts of this presentation 2 years ago. So you'll have the chance to see how this evolved. And essentially, I'm interested in what happens when we try to use machine translation to translate sentiments. And especially when we try to translate sentiments expressed in social media, in tweets. Yeah, so I'll get started. The structure of the presentation is roughly like this. I'm going to talk, I'll have a quick introduction about user-generated content and why we want to translate it. Then I will talk about challenges when we try to translate this user-generated content. I will show you some solutions we developed to improve the translation, and then I'll have conclusion, final thoughts, and I'll try to keep everything on time. So maybe we have a bit of time for discussion at the end. So yeah, just what user-generated content is. I'm sure all of you are familiar with this notion. Just a few reminders. User-generated content is a post on Facebook, and you can see here a beautiful photo from my hometown. And it's not just because it's pretty. Also, I'm going to refer to this later. But essentially, someone decided to post this link and the photo and say, "Hey, look, I have some old photos of Sighișoara." User-generated content can also be posts on Twitter, and here you see an example of a post about Romania joining Schengen, and here the author expresses their opinion, views about the whole process. And a recent development is the fact that you can translate the tweet originally Romanian. If I don't speak Romanian, I can use translate tweet, and then I get the translation in English. And then when I was preparing the presentation, I was looking for trendy things on Twitter, and I came across this post, and I have no idea what it is about, in which languages is posted, but I would really love to know what is the link between King Charles III and this photo. So yes, it is a post by someone, but the information is obscure. I don't know what it is, and I would like to know how I could translate it. All this is user-generated content. And why this user-generated content is useful? Well, it's very important, especially when we refer to social media, it's very important to be able to assess the mood of people. Companies, organizations use automatic processing of user-generated content on a regular basis to find out what people think about them. This is very valuable information because it's unsolicited feedback. It's not that someone is walking around with a survey. It's people expressing their views about companies' products. So it's very useful when it's about when a company wants to take a decision. When us as customers want to purchase a product, we always have a look at reviews and decide, is this a good product or not? So this user-generated content is very valuable. Also, user-generated content, and especially information posted on Twitter, is used to gain information in real time. Quite often, even if you go to an online website for online newspaper, these websites are too slow. They don't update on a regular basis. The updates may come in a matter of hours. On Twitter, you can get information in real time. So it's particularly important if you track some kind of crisis. If you want to see what happens, you want to get real-time information. Processing user-generated content is difficult because it's very messy, and you can see some examples here. It uses non-standard spelling and grammar. It has lots of typos, grammatical mistakes, and this is especially the user-generated content that is produced by users, not by organizations that try to use social media to promote themselves. Uses hashtags a lot. You can see the example here where still hashtag devastated and hashtag sad and so on. So it is that the hashtags are part of the text, making everything more complicated. Sometimes emoticons, emojis are used to express ideas. So we don't use words, we use pictograms. It's quite common that code switching is used in this social media. So if we think about the various communities in the UK, it is not unusual that non-native speakers will write something in English and then use words in their language. So they keep switching between languages, making all processing complicated. There are also some features like all caps to emphasize, no punctuation, and ultimately user-generated content is very messy, making difficult to process using computers, using NLP. At times it is not reliable, so there's always the question of, is this real news, is this fake news? It is contradictory, it represents views for different people. So when we want to use information from there, we'll never know for sure whether this is something we can rely on. But another bigger problem is the fact that it's not always in a language we can understand, and it is too much to be translated manually. So the question is, can we translate it automatically? For example, when we want to purchase a product, we would like to be able to read the reviews in a language we understand. And that's a use case for using machine translation for user-generated content. Also, all the news that are being generated in other languages may need to be translated. And when I say news disseminated using Twitter, would be useful to be translated in English or another language we speak in order to gain a good understanding. However, the big problem with this user-generated content is that it very often expresses sentiments, emotions, opinions, and small changes, small mistakes made in the translation of these sentiments could change the meaning of the content dramatically. And this is something that I'm going to focus in this talk. So that was a quick introduction to user-generated content and why we want to translate it. Now, where are we in terms of machine translation? I'm not going to give you a lecture about machine translation. I'll just show you a few headlines. And we have this published a while ago. AI translation advances are now posing a risk to jobs. So translators are out of business. Will machine learning AI make human translators an endangered species? Is the era of artificial speech translation upon us. And very recently, Meta's No Language Left Behind AI can now translate 200 languages. So this is these are the headlines that are published in press. This is something that we hear a lot from researchers, especially working on more computational side of machine translation and working less with actual translators. We have the impression that, oh, machine translation is a solved problem. And yeah, if we think about how much it progressed in recent years, neural machine translation had made some very, very big steps forward. The quality of output produced neural machine translation is very, very high quality in comparison to SMT, and or even if we go to rule-based translation, that's miles behind. But still, there are lots of problems, and we need to wonder, can we really rely on machine translation to translate this content? So why we would like to translate user-generated content, and why we need to worry about machine translation user-generated content. First of all, an increasing number of platforms offer this option to translate content. If we go to Twitter and you see a tweet that is not in your language, whatever language you have set up for your computer, you'll have the option for many tweets to translate the content. So you would like to know, is this translation reliable? Can I use this option? More worryingly is that in some cases, you don't even know that you see translated content. So a naive user may go to the web page and read in their language and get misleading information because of the mistakes introduced by machine translation. This is the case with Twitter for some languages. I understood that in Brazil, users can see content already in Brazilian Portuguese, regardless of what was the source language. Recently, I read that Airbnb now is showing all the reviews in the language of the visitor to the web page. So you don't even know that, well, obviously there will be an icon indicating this, but a naive user may not be aware, may not understand what exactly it means. So they will assume that this is how the text was written initially. And this is slightly worrying. It's the fact that the user will not be aware that they are consuming machine translation rather than original text. It is a great way to access information. So definitely, if we can have reliable translation, we can access much more information that we would do by using only one language. And it's enough to think about the case of accessing reviews about products. But the big problem is that it can introduce mistakes. And yeah, some of the mistakes are silly. Some of the mistakes can be identified by the reader, but some of the mistakes can have quite a dramatic impact. And there is a well-documented case that happened about 4 years ago. It made the news. It was published in The Guardian, where a Palestinian posted a tweet, something along the lines, "Good morning." And because this was posted in dialectical Arabic, this was translated as "kill them." And he got arrested by the Israeli police and got into troubles. And this was just because the Israeli police was monitoring a number of threads, keywords on Twitter, and they relied on the output of machine translation rather than their understanding of Arabic. So it can introduce mistakes, and these mistakes can be quite costly and embarrassing. Okay, so it's a bit difficult to have this do this interactively. Just a few exercises for you. Do we trust machine translation? I don't know. I hope you can see the text well enough. So earlier on, I showed you a picture of Sigishwara, and this picture, this post on Facebook, was going to a blog with photos from Sigishwara, and on the blog there were various comments. So someone commented on the post, and this is his post. This is his comment. And yeah, looking at this text, I went, oh my God, this is horrendous, Romanian. This is so ungrammatical, non-standard spelling. So do you think machine translation would perform good or bad on this? And yeah, I won't wait for your answer. Just you can make your mind. And surprisingly enough, the translation is good. Yeah. So especially given that the input was so horrendous, I'm pleased to say that Google Translate managed to figure out quite well and actually correct some of the non-standard spellings. So it's an acceptable translation given the input, and the mistakes that are in English are essentially due to problems in poor sentences in Romanian. Another example is a tweet about the war in Ukraine, and what you see here is the automatic translation from essentially Google Translate, that because Twitter is using Google Translate. And when you read it, it doesn't make sense. So if you read, it's this double negation. Please continue to talk about it now. In no case cannot be silent. And that doesn't make sense. So a user will realize, oh, hold on, something is wrong with this. You can't, the meaning of the sentence is wrong. And yeah, if you look at the source, actually, it is a mistake of machine translation. So it became this kind of double negation that makes the head spinning, and it can be spotted by a user that it is a problem. So now the question is, if you as a end user see a translation, can you rely on it even if it doesn't seem to make sense? So again, an exercise for you. This is the automatic translation from Google Translate of a review of a hotel from Sighișoara, and the review was written in Romanian, and this is what, and the quality of the text is quite good. This is a big thing with neural machine translation. The translation makes sense. The translation is very fluent. It's not like the old days of SMT, where suddenly you have a word salad and doesn't make sense. No, the problem with neural machine translation is that it's able to produce very coherent text, but we don't know for sure whether the quality, that the information in the translation matches what's in the input. So here I highlighted this sentence. The main advantage was the location and the fact that I always heard the trains in the room of the pension. And you go, ooh, what? Do I really want to hear the trains from my room? So now think about it. Is this correct translation or not? And funny enough, it is a correct translation. So someone really liked to hear the trains from their room. So there you go. But this raises some big questions. Can we rely on machine translation when we translate user-generated content? What we would do if we didn't have the source? How can we deal with this text? So there are some big issues about translating user-generated content using machine translation, and this part, the next part of my talk will look at what kind of problems machine translation introduces when we translate user-generated content. And the focus is especially when, as a result of the translation, the sentiment and emotion gets distorted. So a study that we did a while ago was to look at what kind of errors Google Translate introduces when we translate tweets. We used a number of languages. So we took data sets that were used in Semmelweis task for emotion aggression detection. The reason why we wanted to do this is because we wanted to have a data sets that were already annotated with sentiments, emotions. So the source language was English, Arabic, and Spanish, and we translated them to English, obviously Arabic and Spanish, to English, and then everything that was in English to Romanian, Arabic, Spanish, and Portuguese. We focused on the emotions that were about joy, fear, aggression, and anger. This was taken from the annotated data, so we didn't have to annotate. And what we did is when we did the translation into English, we used an automatic classifier to determine the emotion. So if we did Arabic, Spanish into English, we did a classifier for English. And for language pairs where English was the source, so for example, English, Romanian, what we did is we did back translation from Romanian into English. And again, we used the same emotion classifier. And what we did is we looked at pairs where the emotion changed as a result of the translation. Now, we were aware that this may introduce some mistakes, that emotion classifiers are not perfect. But what we wanted to do is we wanted to extract potential mismatches. So this wasn't, we wanted to end up with a set of sentences that can be manually analyzed. And so what we did is we had 400 times 400 translations from English. So we had into Romanian, Arabic, Spanish, and Portuguese. And then we had 1,500 sentences from Arabic and Spanish translated into English. And all these pairs were manually analyzed to see what kind of errors they have and whether we can identify the type of errors. We had a preliminary experiment, and we identified that the main errors that lead to wrong translation of emotion are hashtags, non-standard orthography, idiomatic expressions, polysemy, and grammar. So grammar covers both bad grammatical structure, but mainly linked to negation. We annotated a maximum 2 types of errors per tweet, because quite often it's not only one error, but the big challenge was that sometimes it was difficult to understand what is the main source of error. Sometimes the translation was so bad that you couldn't figure out, is this because of a hashtag? Is this because non-standard orthography? So the task was quite difficult. When we analyzed the mistakes, we noticed that most of the mistakes were in Romanian and Arabic. We don't quite know why is that, whether this is a reflection of the quality of machine translation or the fact that the annotators, obviously native speakers, had different strict guidelines, what is a mistake and what not. Interestingly enough, Spanish had the least errors in both directions. So that could be an indication that actually English, Spanish, Spanish, English machine translation works much better. Okay, so looking now at some of the errors, hashtags are used a lot to express opinions, express emotions in tweets, and quite often they are embedded in the text, being used to express, to replace words, essentially. And what we noticed is that Google Translate is very, you can't rely on how Google Translate will deal with tags, with hashtags. In some cases, they get untranslated. So if you look at this example where I highlighted in yellow, bored, no friends, need friends, make friends, DM moms are not translated. They are copied just across into Romanian. Some are translated like depressed, but we consider this a mistake because there are lots of words that are linked to emotion, like bored, no friends, needs friends, that are not translated. So really, if a Romanian is given this translation, they will not be able to make sense of what's going on. At the same time, we discovered that there are some cases where the translation is kind of perfect. Google Translate can deal with the tags reliably. It's lack of faith, so faith is translated with credință, that makes hashtag people, oamenii, afraid. Interesting enough, afraid is translated as teamă, but hashtag disappears. of meeting challenges and so on. So in this way, we see that in some cases, Google Translate is able to deal with hashtags. In others, it is not. And we haven't found any indication, any rule, anything that will tell us when this is possible. So really, we should look into how it's possible to normalize hashtags, which ones. Is there a way to improve the quality of translation by pre-processing hashtags and making the input text more reliable without losing information? Because ultimately hashtags are a very powerful tool to index tweets and be able to retrieve the information. Okay, apologies for the offensive words here. Obviously, we were dealing with aggressive language, so they contain lots of slang and dialectical expressions and swear words, and quite often they were mistranslated. So something that I noticed, I guess from a Romanian point of view, amusing, from an English point of view, surprising, worrying, the very offensive word faggot, which is used to refer to gay people, but it is very offensive, is consistently mistranslated as basun, fagot, so just drops a G in Romanian. Interestingly enough, I tried a few other languages, and you still get fagot, basun in other languages, even if the word does not exist. So that seems to be something linked to the sub-word matching that the neural machine translation does. For some reason, it drops a G. Greek is consistently translated as înțepătură, which is true, but in the context of those tweets, it was meant to be an offensive language. As a result of not translation Greek correctly, the emotion disappears, the aggression disappears, the offensive nature disappears. So the message in the translation is completely lost. And yeah, other expressions like some people are shady gets translated into complete nonsense. Unii oameni sunt umbri. What it means, I have no idea. But yeah, so it completely misses the how to translate shady, and it's very easy to collect examples like this. Obviously, one big question is, do we really want to translate user-generated content that is aggressive, abusive? Yeah, probably there will be some specific cases that this needs to be done for monitoring, but probably not for consumption, not for enabling what I keep joking. I'm going to propose a project where we are going to be able to do multilingual cyberbullying. We can bully people in other languages. So that's not something that we would like to achieve, to be able to write in our language and abuse people who don't speak the language. But probably there will be some use cases where actually we want to be able to monitor and see the translation of swear words and abusive languages. Okay, there are lots of cases of non-standard orthography, which obviously causes problems to machine translation. This example gets mistranslated in all the languages in our experiment. Watching sad BTS video, BC, I'm sad. And this is actually a characteristic of social media language, and yeah, we could normalize some of this text, but we would lose some information because this repetition is usually done to emphasize emotions. Some interesting observation is that actually in the process of translation, the text becomes nicer. And there are quite a few examples of non-standard orthography like this one. He's not even scared of M anymore, which gets translated correctly. Nici măcar nu se mai sperie de ei. Which, yeah, so essentially the machine translation engine implicitly inside it converted this source tweet into more standard language and then translated it correctly. So yeah, funny that this is a way to access information if we don't quite make sense of the source. And trust me, there are quite a few examples where it was difficult to figure out what's there. Okay, in general, negation is a big problem, and you can easily flip the polarity of a tweet by translating negation wrongly. And this is an interesting example. Just kidding, comma, no, I'm fine, which gets translated as Glumesk Nusenbine. So completely different meaning. Some of the translations also have funny effects. We noticed one in Portuguese. A trip to the dentist never gets easier becomes a trip to the dentist has never been easier. So completely different. And yeah, if we're after the emotion expressed in the source, these kind of problems will completely flip the polarity, giving a different meaning. So this was a small study that we carried out. I'd love to be able to go back to it and do it larger scale. The annotation scheme was very difficult. It's because we are dealing with such a messy translation and also source text that probably we will need to revisit the annotation scheme and make it stricter, easier to apply. In some cases, it's not always clear what is the source of error because the input is so messy. So yeah, it would be interesting to see what would happen if we try to apply it again. I did have a master student who tried to apply it to Facebook comments, Greek into English. The experiment was quite small, but the results were very similar. So it seems that these categories are common for tweets and Facebook comments, and are a good starting point for this analysis. Okay, so in that part, the part of the presentation, I showed you the kind of errors that machine translation makes when we try to translate user-generated content. Now the question is, can we fix some of them? Is there a way to develop machine translation systems that preserve the source, the sentiment in the source? And I'm going to show you two papers that I co-authored with one of my PhD students, where we looked at translation from Arabic into English. In the first paper, this is something that we did 2 years ago. We focused on a corpus of book reviews submitted to Goodreads, and this was a mixture of modern standard Arabic and dialectical Arabic. Like with usual reviews, the advantage of using this corpus was that we had the stars assigned by the authors, so that we had the polarity, positive, negative. We took about 13,000 sentences from Arabic and translated them to English using Google Translate. And we used Microsoft Azure Text Analytics to determine the sentiment, just because we had it ready, so we didn't need to use another model. Essentially, it told us the polarity, positive, negative. And when we had the disagreement between the sentiment assigned by the authors, essentially, if it was 1 star, we consider this a negative review. But if the translation had a positive sentiment, we selected this review to see why there is a disagreement. So again, we analyzed about 1,000 sentences where there was this disagreement, and we noticed that the most common errors are idiomatic expressions. So almost all the idiomatic expressions present in the 1,000 sentences are wrongly translated, not a surprise. Dialectical expressions, so reviews that were written in one of the Arabic dialects, almost all of them get wrongly translated. And this is not a surprise, because we noticed that Google Translate has a bias towards modern standard Arabic, so it can deal very well with dialectical Arabic. Negations, more than 70% of examples of negations were mistranslated. Diacritics, in Arabic, diacritics are used a lot, but if these are not written properly, they get mistranslated, and apparently it's quite common that in user-generated content on social media, people don't post, don't use diacritics properly, and contronyms also gave us lots of problems. We don't have in this list hashtags because these reviews do not contain hashtags. The writing is much better, so we don't have the Twitter-like speech with you and so on. It's most of the problems are caused by diacritics. So when people don't write properly, don't use the diacritics properly, and some dialectical expressions. And you can see here some examples of cases that for each of these categories. And for this paper, we decided to focus on contronyms, which are essentially words that have opposite meanings in terms of sentiment. So, and this is quite often relating to dialectical Arabic or modern standard Arabic. So essentially, a word can be translated both as a positive or as a negative expression, and quite often it gets translated wrongly. So what we did is we developed an empty system for contronyms because we couldn't address all the problems at once. There is no corpus as such, so there isn't a corpus to train a machine translation engine. So what we did is we developed a synthetic corpus where we took text from Arabic containing contronyms. We had a list of contronyms. We translated it to English using Google Translate, and then we manually corrected all the contronyms that were wrongly translated. But we did not correct the rest of the sentence. So the focus was on the context where these words occur. We made sure that that context and the contronym is correctly translated to maintain the emotion from the source. And then we also annotated the polarity of each contronym in the context. We developed 3 systems. So we had the baseline seek-to-seek model, which was just trained on the data as it is. We had a transformer model where the sentences were also tagged with a sentiment. So essentially, when we input a sentence to the neural machine translation, we say what is the source, what is the sentiment in the source. And then we also had a second transformer model where we also had a pre-trained vector model created for contronyms. So we tried to push the results better. We did evaluation using Blur, and because everybody uses Blur, but that was more like a safety check, to sanity check. We did not try to produce full correct translations. We did not correct the full translation in order to say we are going to push the Blur score up. It was more a matter of, okay, if we improve the system to translate the sentiment better, do we lose anything in terms of Blur? And the good news is that we don't lose anything in terms of Blur. So the Blur score is going up because we are correcting a few words here and there, and this pushes the Blur score up. However, what we really cared about was about the polarity. Is the polarity of the translation correct? Ultimately, this is what we want to achieve. We want to make sure that when we translate the sentence from the source into the target language, the sentiment is there, the polarity is there. And we see that our 2 transformer models improve over the seek-to-seek model. And also we calculated a distance score in terms of how, using a lexical approach based on Senti-WordNet, how far we are from in terms of sentiment of the source and sentiment of the target. And again, the distance for positive, the first column is positive, the second column is negative, decreases with our system that can handle contronyms. So overall, we're very pleased with the results because we showed there is a way to specifically address the issue of contronyms for Arabic, both modern standard Arabic and dialectical Arabic. Obviously, this is a very specific type of error. The question is, can it be ported to other languages, is this phenomenon present in other languages? Now, I'll just go very quickly through another paper that is going to appear in about 1 month time at the EMNLP, the workshop on Arabic NLP. So the next step is, hey, everybody's doing unsupervised machine translation. Surely we can try to do something. But rather than having unsupervised, we thought, okay, is it possible to have a semi-supervised approach to translate dialectical Arabic? Dialectical Arabic is very problematic because in general, machine translation of dialectical Arabic works worse. It causes lots of problems in translation of sentiment, as you saw in the previous research. And Arabic user-generated content is usually a mixture of modern standard Arabic and dialectical Arabic. So, and the two differ in terms of lexics and grammar. They are quite close, but still there are quite big differences between them. Obviously, there is no parallel corpus to say, hey, we are just going to pour lots of data in that is dialectical Arabic, English into the system, and it will learn how to translate. So we had to be creative and use a semi-supervised approach. From the corpora available, there is a large corpus of standard, modern standard Arabic English. This is the opus corpus. So we had about 3 million sentences, pairs of sentences. There are some small corpora, parallel corpora, about 60,000 sentences, dialectical Arabic to modern standard Arabic, and about 90,000 dialectical Arabic to English. So these are parallel corpora, but they are not user-generated content. They are traveler's guides, subtitles, Wikipedia, nothing like what appears on Twitter. So what we had to do is we had to create our silver standard corpora, and one was from dialectical Arabic to modern standard Arabic. And what we did here is we used the observation that Google Translate will translate from English into modern standard Arabic, not dialectical Arabic. So what we did is we took sentences in dialectical Arabic, translated them to English, and then back to modern standard Arabic. We also did some automatic corrections because we are aware that some expressions are not translated correctly. So we did this, we had a lexicon of sentiments and expressions, and we made sure that they are correctly translated by automatic search and replace. A bit more complicated than search and replace, but this is the idea. And we did the same with dialectical Arabic English, and we had another silver standard. And then we had lots of monolingual user-generated content in dialectical Arabic. That was quite easy to get. Relatively easy. So this is the overall picture. This is the architecture. We developed a classifier for dialectical Arabic. This is a supervised system. We trained it on existing dialectical Arabic. So we were able to filter from user-generated content what is written in dialectical Arabic. This worked about 92% accuracy, which we thought is enough. We trained a cross-lingual language model that used a mask language model and a translation language model. This is based on the work by Lampel and Carnot. I won't go into details. So this is the cross-lingual language model that is trained on the two data, and then we used semi-supervised neural machine translation with two objectives: back translation and machine translation objectives with blue score. Yeah, because the time is short. Details about the architecture in the paper, which I'm happy to share. So we thought, okay, we trained the semi-supervised method for dialectical Arabic. How well does it work? Does it transfer the sentiment properly? We had a baseline which was just supervised NMT system trained on the data we had available. we had our semi-supervised NMT, and then we used Google Translate. In all cases, the blur scores and meteor scores go up when we have our semi-supervised NMT. I don't think we can really compare to the baseline. The baseline was trained on too little data to really say, wow, we do twice as better than baseline. The data is not there. We can't do much about it. We were pleased to see that we do much better than Google Translate when it comes to dialectical Arabic. So in terms of the standard evaluation metrics, blur and meteor, we do better. However, we wanted to see how we do in terms of sentiment, because ultimately what we care is can we translate sentences and keep the sentiment. So we had two evaluations. One was in terms of sentiment distance. So in this case, we used the sentiment intensity analyzer. Essentially, this gives a score based on the lexic in the sentence, and we wanted to see how far we are from the original sentiment in the sentence. We calculated the distance between sentiment in the source and sentiment in the target, and we see that with our method, we are the closest in terms of sentiment. We also had a handcrafted challenge set. So essentially, we extracted 180 sentences that contain big problems that we thought will cause issues in translation, and asked three Arabic native speakers to rate on a scale from 1 to 5 how well the source is preserved in the target. And you can see the results here. So the baseline did poorly. Two of the annotators thought that our system did the best. One of them thought that the overall Google Translate did better, but the difference between our system and Google Translate is very small. So overall, yeah, very, very encouraging results. It seems that this semi-supervised method works well, but obviously it works well for languages that are very close. Okay, so I've been going on for quite a long time. Just initially it was called conclusions, and I'm not quite sure what are the conclusions. It's more about final thoughts. Yeah, where we are now, machine translation is very good. It improved a lot and it's used everywhere, including in the case of user-generated content. So it is here to stay. It hopefully will improve over time and produce better output for user-generated content for more language pairs, because obviously if we deal with language pairs like English, Spanish, French, it works very well, but for Romanian it's not that well, but it's improving. There are lots of challenges that need to be addressed in order to translate sentiment and emotions. And what I try to emphasize in the first half of the talk is that there are several phenomena that need to be addressed individually, and some of them can cause big challenges to end users. We need to be aware of them, and we need to be able to deal with them. And part of the problem is the fact that the output of neural machine translation is so coherent. So the users will trust the output for the simple reason that, oh, they read the text and it makes sense. But really, is it the correct information? Is there a way to flag errors to users, maybe in a similar to quality estimation? It would be wonderful if we had some kind of quality estimation that can identify this kind of errors. And funny enough, WMT shared task this year focused on I can't remember what word they used, big errors. They didn't look at user-generated content, but they started moving towards identification of errors like negation, things that dramatically change the meaning of the translation. I showed you some methods that worked quite well for Arabic, English, addressing specific phenomena. The question is, how can we adapt them to other languages? Yeah, obviously, something like semi-supervised methods will work well for close languages, but what if we have fairly far away languages? We don't know. Other things that we need to keep in mind is we look a lot at blur scores, Meteor, but really, are these the best ways to capture how emotion sentiment are translated? And yeah, another work with my PhD student Hadil looked at how can we adapt blur to also take into consideration sentiments and emotions, because you can mistranslate one word and completely change the meaning of the translation, but the penalty in terms of blue score are negligible. We need to educate users so they are aware of the issues when they use machine translation or user-generated content. This goes very much into the direction of empty literacy, which is becoming more and more of an issue. And yeah, there are many cases where there are cultural issues that need to be considered when we translate sentiment, which is something that we should start thinking when we develop the machine translation systems. And I'll stop now. Sorry, I went longer than I was planning. Thank you for your attention, and thank you to my collaborators, so people who contributed one way or another to the research I presented here. Thank you.
Thank you, Constantin. Now, I think we still have a few minutes for questions. So let me see online. I don't see any questions, but on.
May I? But it came to my mind that since you approach the issue of sentiment, then you come very close to translation of the literature. And I don't think that our times you can find a book, in a library which is entirely translated by machine. So the belletristics is actually needs human translation in order to arrive to reproduce the original thoughts of the author, and the act of translation is quite difficult. Umberto Eco, I think, has written very well this issue because it's a creative act also. So, but I'd like to know a little bit, what do you think about this? Would we arrive to the moment when literature can be, because of course I now can be very easily read Al Jazeera news using automatic translation systems, but I don't think that I would like to read a book translated by Google or even your system. So what do you think of this issue?
Oh, this is recorded, so I need to be careful. Well, I have some colleagues. I have some colleagues in Surrey that are interested in translation of literature, and I always ask them why we want to do we really want to translate literature? And I don't think machine translation is there to translate literature. Yeah, it's a very interesting intellectual problem. It's yeah, we can get some nice papers, we can get publications, but I still have my doubts about using machine translation for translating literature. Why? I don't quite see the point of that, because it's a highly creative process where yeah, you want to have the translator involved, and yeah, it's enough to think about names, how in some cases translation of name is not just replacing the word as it is, but you need to think how you can replace the name in order to keep the opinion about the person. Some of the justification I was given is, oh yeah, that's fair enough, but sometimes you want to be able to translate pulp fiction, something that people want to read quickly. You don't have translators available to do it. I'm still not convinced. In contrast, the research I presented here is about information we need to access quickly. One of the use cases for this is a crisis situation, where you want quickly to see what's going on, And if it's a crisis situation, it's very likely that most of the posts will contain emotions. You want to be able to make sure that the emotions are conveyed properly to let's say organizations that go there to help, Red Cross and so on, so they understand what's going on there. You don't have the luxury of having a translator in the loop. It will take too long. So you want to make sure that you convey the language. Maybe grammatically the output is not perfect, but you want to make sure that you identify when people are in distress, when people need help, and you can allocate the resources appropriately. So it's really about situations where the translation needs to happen quickly, where you don't have the luxury of waiting for translators to post-edit the output to give you the gist. So yeah, regarding literature, yes, there will be emotions, but hey, I don't. Yeah, I have my doubts about that.
Thank you.
Thank you, Constantin. If no one else, I have two more small questions. The first, you said that the evaluation of translated sentiments is difficult. Of course, blue is not enough, matter more or less. I was curious if you try to use the emojis in the user-generated content to validate if the sentiment was positive or negative, or if it works. Because irony may also make you use different emojis.
Yeah, that's a very nice idea. The problem is that you don't always have the emojis. So one thing that I find slightly annoying with the data sets available for sentiment analysis, the ones that are normally released in SEMeval evaluations. Sometimes you have emojis, sometimes they get replaced, which is I would say it's a big loss. Other information like the user is lost. So you need to take the decision based on one tweet. If you're lucky, you have 280 characters, but quite often is much less than that. Whereas there is a whole discourse that is being developed, especially if you think about scenarios where you want to identify cyber bullying, aggression. That's not one tweet, it's a series of tweets. And this information is lost. So in general, I think quite a bit of the research on social media done from NLP perspective misses lots of information. And there are all these kind of extra bits, one being emojis that definitely bring lots of extra information. Now, the interesting thing about emojis is that they are very culturally specific. Apparently, these days, thumbs up is used just by old people, and if you use thumbs up, you show that hey, you are not cool enough. Apparently, kids are using something else. So yeah, I would say translation of emojis is a very big topic on its own, and it goes into that cultural specific issues. Apparently, in Japan, they have millions of, well, not millions, but they have lots of emojis to express their sentiments.
Okay.
But yeah, I agree. That's a very fascinating direction of this kind of text and non-textual information. Yeah, let's call it non-textual information.
And just a thought, it's not a question actually. It's, you said that if the initial tweet, or I don't know, the initial comment was misspelled, after translation, you put the correct translation. Would it make sense to misspell the translation so that the user has the information that maybe the replier was in a hurry, or maybe didn't care so much about the phrase structure? I don't know. It's just a thought, because I see looks around that the time is almost finished. So I just put the idea there. Maybe we can at some point.
I think in many cases, a translator tries to reproduce the error.
Yeah.
Yeah.
Yeah, but I think that's a very nice idea. It's just I'm not quite sure how you could do it. Obviously, you would have a language model of Romanian tweets, and then you will see what is specific. But errors can be so random that. But hey, that's a cool research PhD topic to how to introduce mistranslations in translations, typos in translations. Yeah, thank you.